Pressure. Start with a box containing sand. Now take a heavy brick or bar of metal and place it on the sand. First, place it so that it sinks the least, then so that it sinks the most. What's the difference, since the weight of the bar is the same? Discuss. Snowshoes allow people to walk on snow. The person's weight doesn't change. So, how do snowshoes work? Discuss. Why do bikes for riding on the beach have wide tires? Discuss. Think about what it would mean to get your foot stepped on by a sneaker or a high heel. Which would hurt more? Why? If you're walking on a lake and the ice starts to break, what should you do? Why? Discuss. Would you rather push on the flat side or the pointy side of a thumbtack? Why? Discuss. We've previously learned that two objects can exert a force on one another. There have to be two objects to have a force, since an object cannot push or pull on itself. For example, if I put a book on a table, the weight of the book pushes down on the table, and the table pushes up on the book. The weight of a book with a mass of m is given by weight equals mass times gravity. A new idea, which will have a lot of value, is pressure. To understand pressure, let's first look at the way that a book exerts a force on the table in a slightly different way. Let's think about the weight of the book exerting pressure on the table, where pressure is defined in this way: force over area. In this case, force is just the weight of the book. Area is the area over which the book is in contact with the table. Pressure is the ratio of force to area. The same force can result in very different pressures. If a book is placed flat, its weight is spread over a large area, resulting in low pressure. Placed on its edge, it reduces the area and raises the pressure. Pressure is defined as the force per unit area. Since the units of force are in newtons, and the units of area are square meters, the units of pressure are called pascals, or newtons per square meter. What is the amount of pressure exerted by a 24 Newton object onto a table if it is laid flat and has dimensions of 4 meters by 2 meters by 1 meter? First, write the knowns and unknowns. We know the force is 24 newtons. We know the dimensions are 4 meters by 2 meters by 1 meter. We don't know the area yet, and we don't know the pressure yet. Second, we can figure out the area from the dimensions. If it's laying flat, the 4 meter by 2 meter side would be laying on the table. 4 times 2 is 8, so the area is 8 square meters. Third, substitute in the knowns and solve. P equals F over A, so we have 24 newtons over 8 meters squared, giving us a pressure of 3 newtons per square meter.